We are here with the Open Bionics crew to talk about how they are creating functional, fashionable, lightweight prosthetics for those with a limb difference, and how they are using 3D art and 3D printing techniques to create those arms. When we think of 3D art and the work that 3D artists do, we have a tendency to think about video games, about movies, and about collectibles. So I hope that this interview with Open Bionics gives you a little window into what is arguably a very vast world out there where 3D art is used in a very positive way to help people out. Check it out.
I'm the co-founder of Open Bionics, and over the years I've played many different roles within the company. So myself and my co-founder Joel.
Hi, my name's Joel Gibbard, and I'm the CEO and co-founder of Open Bionics.
And the reason why we co-founded the company was to create accessible bionic limbs for amputees and people born with limb differences. Because the problem at the time was that this incredible life-changing technology existed, but it was far too expensive. And that's because the manufacturing methods were being used were so expensive. The components were so expensive. The materials were so expensive. And we felt like we could innovate on this technology, provide the same level of functionality, but change the manufacturing processes to make it a lot smoother and faster and cheaper.
And I started making robotic hands and learning all about the products that were available on the market and the applications for them. And when I learned about bionic hands for people with limb loss, I discovered that very few people actually had them. But I was inspired by this incredible technology, and I wanted to devote my time to making it more accessible for the people that needed it.
And we have done that in the Hero arm. So it was the first 3D printed bionic arm to market. It's one system, completely customizable. And I think this is like the fun thing about our company. We can change the look of the Hero arm, which is really important to our users because they're individuals with different personalities and they want to be able to change the look of their arm daily, or maybe even if they have like special events and things like that.
I'm lead designer at Open Bionics. So that encompasses designing covers for our bionic arms, like swappable covers where people can customize the look of the arms. But it also involves doing like general sort of look and feel for both the product itself and a lot of the graphics and sort of visual stuff that goes along with that, essentially.
The first thing that happens is that a prosthetist will get a model of their arm, which could be physical or digital from a 3D scan. We feed that into our software algorithms to create the bespoke Hero arm for that individual person. And we then export the files for the 3D printers, 3D print them, and then we assemble everything together into that person's Hero arm.
It can be more tricky than you might expect to go from a 3D model on the screen to an actual product via 3D printing, which is how we do everything. Because my background is product design, like hardware product design. But in the past, I'd only really ever used 3D printing for like quite early stage prototyping, really. And most things like the final product would be like injection molded or, other processes that are quite sort of established for making final products. Whereas 3D printing, it's kind of still almost a bit in its infancy for making final production parts. So there's a lot of stuff that we have to do there to get it to work, I guess.
I just want to say, by the way, Samantha, this is something that I have never said to you before, but I love your family name, okay? If I was to become a doctor at like some point, I would like to be called Dr. Payne. I think that's just a really cool name.
All of my friends are disappointed that I didn't go down the doctor route.
Nice. So we worked together on essentially on one of the prototypes for one of your arms there. I don't remember the year exactly. It was a while ago. That was like 2014, maybe 2015. It's been a while, but essentially we were working on a Deus Ex inspired arm there. And it was quite clear back then, essentially, that we had very similar values around the idea that prosthesis, these sorts of things, like it's not just a medical device. It's important that essentially this is something that people can really value as part of their identity there, that people really have a chance to customize those, to really make it their own.
Like, I'm not trying to hide the fact I have no hands. It's not something I'm ashamed of. It felt like at this point, everybody was just trying to hide my disability.
I just love that idea of building prostheses that really go beyond the simple act of being a medical device, but that also allows someone to express their own personality through what they are wearing there. So I think that's really, really cool, the kind of difference that you are doing in the lives of people.
Yeah, it was a really fun collaboration, and I'm really grateful to the team there for working with us because of all of the reasons that you just said. These bionic arms, I mean, you're making you're making an artificial limb and you have hardware. So you get to just choose what it looks like. You get to choose the hardware you use, materials you use. And for a long time, engineers just designed for a clinical problem rather than talking to the human that was actually going to wear the bionic limb and listen to them and listen to their requirements. And something that we did very differently was that we worked with the end user, the person who actually wears the bionic tech every single day, and got them to design their own limbs. And they didn't want anything that looked human. They wanted things that were super cool, very stylish. Like they wanted to make their friends jealous.
You're a superhero. Look at that.
I want to confirm. Incredible.
And I think the DSX arm is a good example of that. Like it's super cool. It looks really high tech. I've got a prototype here from the year that we made it. It is quite old now. This belongs to the museum. It's just so sleek and stylish. Like who wouldn't want to wear an arm like this?
I never asked for this.
In the game, like we kind of pushed that to an extreme, and we're like, at some point, these will be so much better than actual biological limbs that at some point we kind of wonder if people won't actually want to get their own limbs chopped off just to wear some of these, So
we already get comments from people being like, wow, I wish I could wear this, or I wish I had a limb difference so that I could wear this, because they may be a super fanboy of a particular movie or video game, and they're like, wow, I really wish I had a limb difference so that I could wear this.
Dude, wow.
But unfortunately, the functionality of the tech just isn't there yet, so I wouldn't recommend it.
No. Yeah. Tell us a little bit about the different prototypes, because I saw that there was also at some point a Metal Gear Solid 5 arm. Snake. I saw that now there are Black Panther arms. So like you are all collaborating with all these different really big franchises. I think it's really cool. Like I can kind of imagine myself, if I was a kid, to like actually be able to wear one of these arms that I can see in like movies and like games, like that must be so awesome for someone who's like young to have the actual chance to do something like that,
Hi, Jim Cameron here. As a movie maker, I've always been inspired by technology and what it can achieve. So we decided to have the Alita design team work with Open Bionics.
And we've helped create some arms for you in the form of the Alita Berserker body.
What?
You have shown what strength you have on the inside, and that really represents Alita.
A lot of the feedback we've had from young children is that previously when they've been at school, they've attempted to hide their limb difference, or they felt they've been made to feel shy about it, or they've been given a tool that makes them feel worse about their limb difference. And so when we've had children like that who have that lived experience and they come to us and they give us that feedback, and then they go to school in a few weeks' time with wearing the official Iron Man bionic hand, the difference in perception is huge. The confidence, the body image, they really embody that kind of confidence. It's quite funny because we're working with hero stories and superhero stories. And for us, it was really important that the kids are positioned as heroes. Like we want them to be the hero of their own story. We want them to feel very empowered. We want them to own what makes them unique. And I think that this design does that.
So here, this has just got like sort of standard blue covers on it. But yeah, so the hand, everything from the wrist down, obviously, this is one of 3 sizes. We measure your hand and pick the one that's the most appropriate size to match your other hand, essentially. But that's the 1 of 3 thing. But everything from here down, all of this arm part, this is all completely custom. So, we take your arm scan, we measure, if you've got your other arm, obviously some people will be missing 2 hands. But if you have your other arm, then we'll measure like the elbow to wrist distance and match it to that. Just get the cover off. So this bit in here is, I don't know how well you can see. This is like a sort of flexible rubber bit in the middle. So we call that the liner, or socket, sometimes it's called. This is like a hard frame. We call it the frame. It's like a sort of like lattice material stuff. And that's kind of like what gives it this structure, the rigidity. This here is a thing called a BOA, which is, you get them on ski boots and things like that. It's like essentially a way to tighten things without laces. So it's just like a thing that you like ratchet these up like that. And then the covers attach on top of the frame here. So they snap on with magnets, and then that's held in. But yeah, so everything, so like the liner, the frames, the covers, all of them are custom and are essentially based off your arm scan. So the arm scan itself is like the starting point in the 3D CAD.
this is not just a lifeless piece of plastic. This can actually move. This has functionality. People can actually feel, well, perhaps not feel things, but
Not yet, maybe one day, yeah.
But it can certainly grab things. It can give handshakes. I've also heard that there's also some movement now that's possible with the wrist there.
We just have a button that allows you to spin the wrist like 180 degrees like this. And actually for a lot of situations, it's perfectly good. In future, like, we're definitely exploring other things that we could do with the wrist in terms of like having a powered wrist or giving it more axes of movement. But that actually gives you a lot of functionality, just being able to spin the wrists like this, essentially. Yeah, the fingers are all moved by motors, and it's actually doing, this is like the calibration routine when you turn it on, it sort of moves all the fingers just to make sure they're working.
I love the little mechanical sounds, by the way. It like really makes you feel like a pretty cool cyborg.
There's always been this assumption that the best thing for someone who's missing a limb is to pretend that they still have their limb. And I always think, like, our whole sort of company ethos is not doing that, essentially. But one of the reasons why I think that's such a misguided sort of way to attempt it is because it's never going to fool anyone. Like, it's a robotic thing, and we don't have the technology to make a bionic hand that doesn't make a noise. So even if you make a perfectly matched skin tone, one that visually otherwise would fool people, as soon as you move it and it goes, like when you meet a new person, you spend the entire time thinking kind of like, have they noticed yet? Have they noticed yet? Do I have to have this conversation? When they have one of our arms, it completely changes that whole dynamic where it's kind of like, suddenly people are like, whoa, cool arm, what's that? Where'd you get that? You know, it changes the conversation completely. So that's part of the reason really why we have gone for this sort of like quite sci-fi look, and having the customizable covers and make it sort of an expression of your personality, how you can choose what colors you want and what designs you want and customize it yourself, essentially.
That's really cool. Like, it really empowers people. It makes those arms practically like a fashion statement to a certain extent.
With having that swappability, it's like, it means you can have a more formal set. You can have you can have your everyday ones. You can have, if children get them, they can be, kids go through phases and stuff. They might be into one superhero one year, but 6 months later they might be bored of that bit. So you can just change it, you can customize it. So I think that's really powerful. And yeah, like you say, like empowering, that's a big part of the ethos, really.
This morning, my daughter Chelsea was showing me the video of you with your R2-D2 arm. Oh man, that is fantastic.
So from a 3D scan, I mean, it all starts and they go to either our own clinic, or we have like sort of network of partner clinics that we work with.
Is it possible for them to do that themselves with a phone? Like, is the resolution of the data good enough for that? Or
not really? We have explored that like in quite some depth. There's just a lot of potential issues of like getting the customer to do it themselves. It's like there's a lot, it's a bit of a knack to getting a good scan, I guess. And like there's also another aspect though, which is because this is a medical product, there are actually sort of like regulations around, really they have to be seen, like have a clinical assessment by a qualified prosthetist is the name of the role, like someone who's like a specialist in prosthetics. So yeah, this is like an example of one of the arms. This is actually Black Panther covers that we just did really recently. So this is like the kind of thing that I'm working with when I'm designing covers. This is Blender, obviously, and the sort of patterns that I put on it is all like done with displace maps, essentially. Black Panther is quite interesting because there's a lot of like obviously African influenced patterns in here. Some of these are sort of, the inspiration for these is like taken from his mask. But yeah, a lot of the details in here are sort of taken from a bit of like kind of like a mix of the first film and second film stuff. This sort of panther head detail here, which has a bit more sort of like, I guess you'd call it sculpted, faceted details on it. The way I do that is actually make them in Blender and then make it into a displace map. We actually have two types of arm. This design here, this is what we call an internal battery arm, and you can tell it's internal battery because the split line is down in the middle here. And basically what that means is this is for people that have like quite a short residual limb is the term, like the remaining part of their limb is quite short. So somebody that would have this arm, maybe their arm would come to sort of like roughly like here sort of thing, like it would be taking up like this space. And what that means is we can put the battery in this part of the arm here. So the battery is removable, you can take it out to charge it, but it sits in here. So part of what the covers do is cover up the battery location. This is the other type, this is what we call the external battery arm. And that has, you can see here, there's a bit of a bulge sort of below the elbow. And that's because a person that would have this arm, maybe their limb comes all the way down to here, so there's no room we can't fit the battery in this location anymore because their arm is taking up that space. So in that situation, we have the battery underneath here, and the split line is a bit different. It's sideways because you've got this bottom cover that covers the battery location. So yeah, there's two variants of the arm.
I think it's actually pretty cool to see more what are the real life applications, not just of 3D, but also of Blender, because Blender still has that reputation of being like a hobbyist software, but not like a professional software.
The idea of using this kind of 3D software, which like you say is like more typically used for games, movies, really it's in some ways quite unique in product design because our product is 3D printed. It's quite a sort of new frontier, I think. So we don't use Blender for the actual hand components anymore, but for the covers, it's still extremely useful because the covers are essentially quite a simple part. They're just essentially like a plastic shell. So the Bionic hands that we make they're like one of 3 sizes. So they're essentially kind of fairly standard components. So that's more like kind of, a traditional product design thing where you make a few sizes. But the custom part of the forearm means that, with doing like the covers and stuff, when I come up with a cover design, it has to be able to sort of stretch and fit like every shape of arm that we might get. And you maybe would be surprised how different the shapes of some people's arms can be. So it has to be quite a lot of sort of flexibility in that, I guess.
How much does it cost for someone to acquire one of these arms, and the typical time delay that it takes to go through the process of creating one of these?
That is a great question, and it really depends where you get the arm from. So Open Bionics, we see our own patients, and we also deliver the Bionic arm to clinics outside of Open Bionics. So those other clinics, they set their own price point. Open Bionics UK, the cost of the Bionic arm starts around £10,000. And with the warranties, there's a subscription package. If you want loads of covers and extra features and upgrades, that goes up to like £15,000. The time it takes to get the custom arm, it really depends on the clinic and the clinician and what kind of method they're using to capture the limb shape. But it can be anywhere from 2 weeks to 2 months.
2 weeks is extremely short. Like there's plenty of I order stuff on Amazon all the time, and it takes longer than that. So
we want to get to a point where we can deliver every single time within 2 weeks. We have to change our manufacturing process to enable that, but we have achieved that time, which has been awesome. The reason we're able to do that, and it's such a USP to our company, is because of the automation system that we've designed, because we are using 3D modeling, because we are using 3D printing. The industry standard for a custom arm like this might take anywhere from 3 months to 6 months to 9 months. It really varies.
Right now, as far as where you're situated, so you are doing a fundraiser to bring the Hero arm. So that's your latest arm there. So you are looking to bring that to more countries, right?
Yeah, that's what we're working on. It's been a very busy 2 weeks, and we're working on that for the next sort of month or so. And it's a fundraiser to make sure that we can bring the Hero arm to at least 10 more countries. We want to be able to launch in 10 more countries. Currently, you can get the Hero arm in the UK and in the US, but we receive emails from kids and adults all over the world who need access to this technology, and it's been bugging us and frustrating us for a long time that we haven't been able to reach them. So we're raising investment on Crowdcube to reach them finally. So we're really excited about being able to have users all over the world.
Very cool. And that crowdfunding is open to whom exactly?
Yeah, so the Crowdcube is open to UK investors and EU investors. So if you're in France, Germany, UK, Italy, Spain, you can visit our website and sign up via our website, or go to Crowdcube and look at the Open Bionics campaign. US investors, you can't invest yet, but you can sign up to our website and we will notify you if we run an investment campaign in the US. You can go in for a minimum of £12, and that gets you 2 shares in the company, and that helps fund the R&D, and it helps fund the growth of the company. And I think I should probably mention the capital at risk disclaimer. So invest aware and read all of the terms and conditions on the website.
Yeah. Tell us a little bit about the little girl there, Tilly.
Tilly lost both of her hands to meningitis when she was a very small child, a baby, basically. And her mum went through the worst time ever, watching Tilly fight for her life, winning that fight, and then learning to adapt as she got older. And Tilly's mum basically promised her that she would find her hands one day. Like one day she would be able to replace that functionality. We met Tilly when she was 9 years old, and she was the first person to ever wear the Adam Jensen arm, which was an interesting
Which is
choice.
really cool, yeah.
Yeah, I love that. Like, and the first person to wear the Iron Man arm was a 14-year-old girl in LA. So yeah, I really like playing with these ideas around who gets to wear these super high-tech bionic limbs. Yeah, so a 9-year-old girl was, of course, the obvious choice for Adam Jensen's arm. And she was at the panel. So when we gave her the DSX arm, she came with us to Comic-Con. Do you remember? She stole the show there.
Oh, she stole the show for sure, yeah.
Tilly has taught us so much about how people with no hands use bionic limbs and how they adapt and ways in which that they adapt better with technology. The hands need to be dexterous enough to hold really fine objects, really small objects. And we learned this because Tilly was really fond of doing makeup tutorials. She's brilliant. She also came up with the freeze function of the bionic limb. So she kept noticing that when she was holding something that she really didn't want to let go of. I think she actually learned about this when she was flipping pancakes with her bionic hands. That sometimes the pan would fall out of the hand because she was jerking, and the jerking motion sent a false positive to the sensors that controlled the fingers. And so the fingers would accidentally release. And so she was like, look, I really need a function where I can just, no matter what kind of movement I'm doing, the hands aren't going to release. And that became a really popular feature for the hand.
Sometimes you might, say you picking up a glass of water or something with the hero arm. You really don't want to accidentally send an open signal when you don't mean to and drop it. So freeze mode, the whole idea of that is that you kind of freeze it in the closed position, and then it will only actually release once you hold a closed signal for a number of times. I forget what the time is, but it's basically just a way to make sure that people can have some peace of mind that they're not going to accidentally drop things.
One of the things that I'm extremely impressed about really with these arms is just how much technology fits within such a small device, in terms of, so, and I would really love to hear you talk a little bit about how different sensory inputs perhaps are communicated from the wearer all the way down to the figures themselves.
The hero arm is, the sort of name for this type of product is a myoelectric bionic arm. Every time you flex a muscle anywhere in your body, it generates a small electric signal. And so you can use sensors to pick up on those signals. And so basically, if you're missing a hand, you still have the muscles that would flex the muscles in your hand and that would open and close your hand. Those muscles still exist in your forearm. When you sort of flex those muscles, it picks up those very, very small electrical signals. So there's two sensors on the arm. There's one on the inside of the arm and one on the outside. That's what these sort of oval things are here. So on your arm, it would be one here and one here. I can activate it just by tapping it with my finger, but if you imagine someone's arm was in here, it would be flexing a muscle in there. So this is the closed electrode here. So if I tap that one, and then if I tap this one, this is the open one. And I'll see the hands out of shot here. Trying to fit it all in screen.
Nice.
So yeah, right there, that's the open one, that's the closed one. So essentially we only have two inputs, and everything we have to do with how the hand operates is kind of finding clever ways to use those two inputs to get more functionality. So the button on the back of the hand is one of the ways that we do that. So you can switch between grip modes using the button on the back of the hand. So if I press that one time, so that should be a tripod, we call it, where just two fingers go. So yeah, that's the tripod one. And then if I was to press that button again, it'll go to a pinch grip. There you go, that's a pinch grip. So the hand button sort of switches between groups of grips, but we also have it set up so that if you just hold an open signal, it will change to a different grip as well. So this currently is, we call this fist grip. So this is kind of if you wanted to grab, say a bottle or a handle or something, it's all four fingers go down on the thumb. You can see where the thumb is there. But if I hold an open signal for a bit longer, there the thumb is moved, and that's now what we call a hook grip. So that would be you could use that either for a thumbs up, but also to hold a briefcase, say, or a shopping bag or something where you you know, maybe you're carrying something this way up and you just want the fingers without the thumb in the way. Yeah.
How does it work from a standpoint of, let's say that you want to pick up a glass, you want to pick up an egg, you want to pick up, you've mentioned groceries there. So I assume that there's probably weight considerations, as in like the arm can only carry X, Y, or Z amount of weight because there's of course motors in there and stuff like that. How does that whole process work? And can you actually, could you pick up something that is very fragile, and are there any kind of sensors in there that detects the moment that there is resistance when the grip is closing?
Yeah, you're right. Of course, there are weight limits on what the hero arm can pick up. That's set by a number of things, like just the materials the hand itself is made of, but also actually like the what we call the suspension of the arm, which is basically how well it's held onto your limb. Because you could have a situation where the hand could carry, I don't know, 100 kilos, but is it going to stay on your arm? That's a whole different question. So
yeah.
And so the way the suspension works in the hero arm is kind of like you have on your elbow, you have these two bones either side. It's quite kind of hard to see them, but you know, you've got one here, you've got one here.
Yeah.
Yes, well, very good. Oh, of course, you're like sort of anatomy specialist.
This is a character art channel.
Yeah, of course, right. Everyone watches kind of like, well, duh, obviously. So yeah, the hero arm, there is definitely a weight limit to what you could carry without it falling off your arm, essentially. We see people that use them in the gym, for example, like they'll take the hero arm to the gym and do like, you know, weights, bench press, that sort of stuff.
Seriously?
Yeah,
so
really,
cool.
yeah. I think potentially it might
crazy.
be one of those things where like we don't recommend you do that, but we definitely get videos of people doing it that come through and like, oh, okay.
We see a lot of videos from users who really excitedly send in these videos of them doing extreme stuff with it, and we're like, oh guys, that is in the user manual not to do. And they're like, it's so cool. And I'm like, it is cool, but I'm not allowed to say that.
Yeah.
We've had people, we've had users use the Bionic arm for like motorboat racing, and it's not waterproof, and yeah, two hands on this wheel for motorboat racing, and it's just like, oh, that seems like a disaster. With skiing, and like it's cool, like yeah, it can be used for skiing, but if you fall and injury with skiing is already high risk. What else have we seen? Oh, we've seen all sorts, and it's just cool. Like it's a tool that people wear daily, and they get up to all sorts in it, and it's fun to see the range of activities that they use it for, even if sometimes they ignore the user manual.
Can they also carry and pick up very fragile things at the same time?
They can. You can definitely pick up, say, like an egg, for example, or a grape. They don't have any particular sensing that's telling you, like, I guess, like, oh, be careful, you're pushing too hard on this. But what they do have is proportional control, we call it, where basically the harder you tense the muscle under the sensor, the sort of faster and with more force the fingers will close.
Oh,
so
that's really cool.
Using that, just by kind of doing like a light tense, the fingers will kind of just gradually close in. I can't really demonstrate that to you because I'm just tapping the sensors with my finger, and essentially that's like 100% for signal. It's just the way it works. But when it's actually on your arm and it's a real muscle signal, you have that control to kind of like very slowly make the fingers go in, and they go, you know, the force kind of increases as they go.
In the industry, typically a prosthetic limb would be handmade in a workshop at the place that it's delivered. But what we did was we used the very latest technologies, 3D scanning, 3D design, and 3D printing, so that we could make bionic arms ready to fit to the patient. Not only have we developed a bionic arm, we've developed a process that can be applied to make custom prosthetic limbs at scale.
The 3D printing part is very interesting because that's a fabrication process that it really is revolutionizing quite a lot of things there. You know, like even like building construction. Like you see buildings now getting 3D printed because that just makes it a whole lot faster and cheaper, and sometimes simply leads to better results too, because then you don't have to deal with a whole bunch of little pieces of whichever material is used all kind of stuck together there. You just get something that is more durable and is more resistant too, because there's less joints, there's less soldings left and right, there's less of these kind of things that could actually create weaknesses along the structure. When
you design parts for a lot of traditional manufacturing methods, like injection molding, say, like at Dyson I would design parts for injection molding. It's like the way it's made is like completely inherent in the design process. You don't really like make a part and then be like, okay, how am I going to mold this? It's just like you have to be thinking about it constantly, because you have to think about like a mold will come apart like this. So if you've got any undercuts, like any sort of bit of geometry that goes like under like this, then the mold would never be able to get off it. And you can do all sorts of crazy things with having like molds that go like shut like this, but then there's also other bits that slide in like this, and then to open the mold they slide out this way and then this way and then this way. But that gets like really expensive, really difficult. The parts fail more often, all that sort of thing. With 3D printing, it's like you pretty much have complete freedom to design any shape you want. And in general, like 3D printing is like so much design freedom compared to injection molding or, getting things like machined out of metal and that sort of thing. And I think also like 3D printing is at a really interesting stage right now, like even just completely separate from prosthetics, I guess, that it's at a time where kind of like some of the original technologies of 3D printing are getting to the point now where, like in the past, it was quite hobbyist sort of stuff. You could make, small little, I don't know, figurines or whatever, like something for your mantelpiece sort of thing, but making functional parts that were kind of useful and strong and stuff was not really that easy. But there's many processes in 3D printing that are getting better and better and better. So in a way, it's like, if you have any interest in making physical items, it's a really good time to be good at 3D, and actually especially good at mesh 3D, because 3D printing is all using mesh data. So I think I mentioned at the start, like the traditional CAD software, they call it, that I used as a product designer as a student and stuff, it doesn't sort of natively work with meshes. You're always like you can export an STL and print them obviously, but in terms of like with 3D printing, they use meshes, and if you're using software like say Blender or 3D Studio Max or whatever, you're very good at manipulating meshes. So it's kind of a good, people that have those sort of 3D skills have there's a lot you can do with 3D printing, which is really cool. I think really cool time to be part of, to have those opportunities, I guess.
As someone myself who do 3D art, right? And as knowing a lot of other people who work within video game studios, when let's say, I don't know, there's a bug within the game and we can't fix it for some reason, one thing that we always tell each other somehow is, hey, we're not saving lives, like we're not, like we're making video games. We're not actually kind of like, we're not doctors. We're not making a difference in the world. We are just entertainers. In a way. So, and we kind of, that sort of allows us to sleep at night. But I think that there's also a lot of people who do 3D art who are quite interested in making a bigger difference in the world, and seeing like how they can actually contribute to the world there in a different way. And I don't think that we talk enough about the different ways that people who do 3D art actually have a chance to make a difference. But I think that Open Bionics, what you are all doing, is really fantastic, because your arms are essentially created in 3D first, and then they are 3D printed out, I think that's fantastic, because not only are you helping people with a limb difference, but also I think, as far as I'm concerned, and for me that was actually one of the biggest takeaways when we had collaborated a few years ago, was that there is a way to use 3D art for the greater good beyond the idea of simply making video games or making movies. Like you personally have given me inspiration as far as that is a concern, to use my own skills to see how can I use those skills to actually make a difference there. And, like we are moving towards a future where 3D content, 3D creation tools, 3D printing is just going to be used more and more in a lot of different contexts, So I just want to say that, like for people who are watching this who do 3D art or want to get within 3D art and are passionate about that, and, a lot of people who will watch this channel, this particular video, are interested primarily on the angle of video game creation and movies. But I think a lot of us too kind of feel as if, like it feels genuinely good to do a difference in the world, to do things that help other people in a genuine way, And so I find a lot of inspiration through what you are doing. It sort of allows me to think of other ways that I can use my own skills to kind of do something good for the world, do something good for like other people. And as people who do 3D art, we have a lot of opportunities to do so, but they're just not as publicized essentially because we don't talk nearly as much about open bionics as we do about, let's say, what is the next biggest video game, right? And that's a bit of a shame, like that's a bit of a shame because I think that we should actually speak more about the real life applications that 3D can have in people's lives and how we can actually use those skills to make an impact in the world. So just for that, I want to say thank you.
Yeah, thank you, Laura. Like your work is incredibly beautiful, inspiring too. And it's interesting that you say that our work inspires you because very clearly, I mean, you were the 3D artist on the Deus Ex Adam Jensen character in ARM, and like that inspired us to create this ARM. So it runs both ways. Like 3D artists do inspire the world, and they do inspire these amazing creations, and art does inspire reality. So we wouldn't have these wonderful, super sleek, amazingly empowering bionic arms that look like they do now without the work of 3D artists. So it's a really nice back and forth relationship. And I think I can totally appreciate that 3D artists want to see their work having a tangible impact. And prosthetics is a really nice physical product that you get to see your work on, and you get to see the impact immediately when someone puts the arm on. There's loads in this space. So like bionic arms, orthotics, spinal braces, cranial helmets. What else? Oh, exoskeletons. I'm so excited for the future of exoskeletons, and we need 3D artists making them look super cool.
I want to thank you for your time. And once again, I want to say thank you for everything that you are doing to make a difference in the lives of those who have a limb difference there, and also for inspiring people like me to use our own skills in a way that can actually truly benefit the world there. So
thank you, Laura. Thank you for giving us the platform and the opportunity to share our work. We really appreciate it, and your channel is awesome, and you're extremely skilled, so it feels like it's such an honor for us. So thank you.
Thanks. And for those of you who are watching this, if you want to help Open Bionics with their fundraising campaign, we will leave a link in the description of this particular video where you can go on their page and you can donate as little as £12, I believe, right?
Yeah, you can invest £12 for 2 shares.
Cool. Well, there you go. So once again, thank you, Samantha. It was great.
Thank you, Laura.